are you, my dear learners? I hope my presence makes you feel relaxed and excited to know what next. Last time we had learned how to write small programs. Now just imagine that you are in a hotel. Some of the hotel services are built in like room service, laundry service, etc. and some are customized like touring to nearby areas, food, spas, etc. according to your own requirements. Process of doing work varies from service to service, but one thing is common. For every kind of work, there is a service available, but they have to be called. Similarly, C++ being a very structured language, C++ program contains at least one function that must be main. Default return type of main function is an integer and its return statement is used for termination of the program. This main function may call other types of functions like a person calling for different services in hotel. After execution of each function, the control of the program returns to main. We can classify functions broadly into two categories. First, library functions or built-in functions or standard functions. Second, user-defined functions. Just like some of the services in hotel are essential or we can say built-in the same way in C++, some of the routines that are stored in library files, that is .lib, which automatically get loaded into the memory. Technically, we can say that library functions are the predefined functions used for some predefined operations on characters, strings, etc. The functions perform file access operations, mathematical computations, graphics operation on characters and strings, memory management operations, data conversion operations, etc. When program is compiled, the compiler looks or searches the function in library and gets it attached to the source program by a linker. They are also called as standard routines. They are declared in various header files. Some of the most popular routines are as follows. Classification routines. These type of routines classify ASCII character as alphabets, control characters, punctuation, digit, uppercases, etc. For example, is alpha is used to classify the ASCII characters as alphabetic. Is space, is upper, is lower are used to check whether the given character is space or in upper or lower case. S digit is used for digit checking. There are many more functions, but it is beyond the scope of this module. You must remember that all these functions are declared in C-type.h and their output is always a Boolean value. Conversion routines. Next we will discuss conversion routines which convert characters and strings from alpha to different numeric representations, that is floating point, integers, longs. For example, to ASCII, A to I. It also converts numeric to alpha representations, I to A or uppercase to lowercase and vice versa. To lower, to upper, they are present in stdlib.h or in c-type.h header files. Input-output routines. Suppose we want to read the data from file or from keyboard, or we need to write data on the monitor or in file, then we make use of input-output routines. These routines provide facilities for inputting, outputting data at stream level and DOS level I/O capability. For example, open, cgets, cprintf, cputs, cscanf, DOS_create, DOS_read, DOS_write, F close, F EOF, F get C, F print F, F puts, etc. These are present in stdio.h or io.h, conio.h, dos.h header file. Graphics routines. Any type of graphics can be designed with the help of different functions available in graphics routines. Inline routines. These routines have inline versions for their functions. The examples on the screen are present in string.h or mem.h header files. Math routines. If you want to become serious mathematician, then use math routines that perform mathematical calculations and conversions. The examples shown on the screen are present in either of math.h or stdlib.h or complex.h header files. String routines. There is one more surprise for you. In C++, you can manipulate strings also. Like, if you want to compare strings, then use strcmp function. For copying string, use strcpy. For joining two strings, that is concatenation of strings, use strcat. There are many more functions available in string.h header file, so play with them. There are certain other types of routines also, but these are most popularly used. User-defined functions. User-defined functions are just like customized services. Remember, like tour services available in hotels. These functions are defined and designed by user only in accordance to their ability. These are discussed in details in the previous module. Let's see an example that illustrates the use of library function as well as user-defined function. In this example, we will calculate area of a circle and square root of a number. You can see here that header file math.h is included. As usual, the function area is declared with argument float. Now just keep watching where its function will be used. This is the user-defined function we are using, which will be defined later. Built-in function with argument passed as 4. This is a user-defined function to calculate area of a circle with radius as argument passed and having value 5. The sample output will be as shown. User-defined function can be further classified as simple, void, boolean, inline or recursive. We have just gone through simple user-defined function. Void functions specifically do not return any value, while boolean functions return only boolean values. Inline and recursive function needs some more explanation, which will be dealt in next modules. Inline functions. As its name suggests, these are small functions that are written within a single line. The compiler expands code from function definition directly into the code of calling function rather than creating a separate set of instructions in memory. It has many advantages, like it eliminates the cost of calls to functions, saves a lot of extra time in executing a series of instructions for tasks such as jumping to the functions, saving registers, pushing arguments into the stack, returning to the calling function. Some of the characteristics of inline functions are: the use of inline specifier does not change the meaning of the function. The inline expansion of a function may not preserve the order of evaluation of the actual arguments. Inline expansion also does not change the linkage of a function. The linkage is external by default. The inline keyword merely sends a request, not a command to the compiler. The compiler may ignore this request if the function definition is too long or too complicated and compile the function as a normal function, so the functions are made inline when they are small enough to be defined in 1 or 2 lines. There are some situations when inline expression may not work. For function returning values, if a loop, a switch or a goto exists. For function not returning values, if a return statement exists. A function contains static variables, if inline functions are recursive. In short, inline expansion makes a program run faster because the overhead of function call and return is eliminated. The syntax is as shown. Some of the significant points to remember while writing inline functions are: all inline functions must be defined before they are called. Number of statements in the inline function must be limited, otherwise it will behave like a normal function. For example, let's write an inline function for calculating cube of a given number. This is an inline function. This is the main function. You can see here inline function cube is called by the main program. As we know that compiler will expand its code, so this statement will virtually become as shown. If main program again calls it with different argument, then compiler will again substitute the code for that. See here. An inline function that the compiler does not inline is treated similarly to an ordinary function. Only a single copy of the function exists regardless of the number of translation units in which it is defined. So this is the beauty of inline functions. Recursion. Have you ever called yourself for some work? Confused? Okay, take this that you can imagine any service that calls itself to complete its own work. Just brush up your brains, dear. What's your reply? Never? But C++ functions have capability to call itself directly or indirectly. That is why they are called as recursion function. That means if a statement within the body of the function calls the same function again and again, then they constitutes a recursive function. It is just like circular reasoning. The problem with this function, however, is that it would run forever because there is no place where it stops. The function would repeatedly call itself until there is a condition to tell when to stop. The stopping point is called the base case. Thus, we can say that a base case is the bottom point of the recursive program where the operation is so trivial as to be able to return an answer directly. All recursive programs must have at least one base case and must guarantee that they will hit one eventually. Otherwise, the program would run forever or until the program ran out of memory or stack space. Let's take a classic example of finding a factorial of a number. To find the factorial of a number, we know that 3 factorial is equal to 3 into 2 into 1. Similarly, 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Have you noticed one thing? Factorial of any number is product of all the numbers starting from number itself up to 1. Now see the solution for this problem with different angle. We can also write 3 factorial is equal to 3 into 2 factorial, that is equal to 3 into 2 into 1 factorial, that is equal to 3 into 2 into 1, or 5 factorial is equal to 5 into 4 factorial, that is equal to 5 into 4 into 3 factorial, which is again equal to 5 into 4 into 3 into 2 factorial, equal to 5 into 4 into 3 into 2 into 1 factorial, which is further equal to 5 into 4 into 3 into 2 into 1. Or in general, you can say x factorial is equal to x into x minus 1 factorial. So we can say that a factorial of x is a product of x and x minus 1 factorial. In other words, we are inductively calculating the factorial. This is nothing but recursive way of calculating any factorial. This recursion will stop when factorial of 1 is calculated. Now let's write a program for this. This is the body of the main program that calls a recursive function reoccur. Here recursive function reoccur with argument as 5 is called by the main program and its value is stored in the variable fact. This is the user defined recursive function. You can see here function reoccur is called again and again with argument y minus 1 till value of y becomes 1. So this is the stop point for this function. Let's explain how it works. So we can conclude with the basic steps of recursive programs. Every program follows the same basic sequence of steps. Initialize the algorithm. Recursive programs often need a seed value to start with. This is accomplished either by using a parameter passed to the function or by providing a gateway function that is non-recursive but that sets up the seed values for the recursive calculation. Check to see whether the current values being processed match the base case. If so, process and return the value. Redefine the answer in terms of a smaller or simpler subproblem or subproblems. Run the algorithm on the subproblem. Combine the results in the formulation of the answer. Return the results. Function with arrays. Do you remember arrays? Yes. Same arrays can be used as function arguments just like any other simple variable. So all the operations on arrays can be functioned also. In order to pass an array to a called function, it is sufficient to list the name of the array without any subscripts and the size of array as the arguments. In C++, it is programmer's responsibility to ensure that index value does not exceed the dimension of an array, because C++ compiler does not detect such type of errors. For example, product of 25 elements in 5-dimensional array will be any garbage value. If we have an array A with dimension 5 and having values stored in it as 1, 2, 3, 4 and 5, then their product should be 120. But we will get a garbage value if we try to get product of 25 numbers or any number of elements greater than 5. Now let's discuss syntax of function prototype, function definition and function call. Function prototype. In the function prototype, specify the array type followed by a square bracket to represent the array. Here, array name and size are optional. These are the examples for function prototype. Function definition. In function definition, we must specify array type followed by function name and the name and size of array in place of array argument. Please note that statement is not ended with semicolon. These are the examples for function definition. Function call. In function call, in the argument part, array is referred by its name only without mentioning its size. Here is the example for function call. Now let's take an example to sort an array of numbers. The declaration of formal argument array is made as follows. The pair of brackets informs the compiler that the arguments mark in an array of 5 numbers. The call to the function sort s, marks will pass all the elements contained in the array variable of size s. The called function expecting this call must be appropriately defined. The function sort is defined to take two arguments, that is the size of the array to specify the number of elements in the array, that is num, and array name, that is arr. The results will be as follows. The marks before sorting is 41, 76, 56, 79, 45, and the marks after sorting are 41, 45, 56, 76 and 79. You might be tired of functions now. I'll stop here. Next time we will start with entirely new concept, that is classes and objects. Watch it out and know about OOPS. Thanks a lot and see you in next module.